Welcome everyone. Let's talk about empirical and molecular formulas. The molecular formula tells you how many atoms of each type of element are present in your molecule. It's quite literally like breaking it open and taking it apart. What's in it? The empirical formula is similar, but instead of being exactly what's in your molecule, it tells you the ratio of elements that are present, and it's the lowest whole number ratio of elements that are present in the molecule. Let's take a look at a couple of examples so that you can see what I mean by this. The compound C4H2O2, that's its molecular formula. It tells me there's 4 carbons, 2 hydrogens, and 2 oxygens in every molecule of this particular chemical. The empirical formula is the lowest ratio. 4 to 2 to 2 is the same as a 2 to 1 to 1 ratio. Its empirical formula is C2H0. Same elements, same ratio. For B2H6, that's its molecular formula. It tells me exactly what's in my compound. But its empirical formula, that lowest whole number ratio, is BH3. For CO2, the molecular formula is the same as the empirical formula because it already is the lowest whole number ratio possible. Your molecular formula is always some multiple, 1, 2, 3, 4, 5, whatever, some multiple of your empirical formula. When you want to determine the empirical formula, there are 3 steps that you are going to follow. First, you need to figure out the mass, the grams, of each element that is present in the compound. Second, you need to convert grams to moles. The empirical formula is a mole ratio, so you got to get to moles. And third, you're going to find the lowest whole number ratio that number of moles you've calculated represents. Let's take a look at an example to see how this works. If I take formaldehyde, it's 40% carbon, 6.73% hydrogen, and 53.3% oxygen by mass. If my goal is to find the grams, considering that a percent mass is always the same regardless of how much you start with, it is easiest to assume you have 100 grams of sample. In a 100 gram sample, you will have 40 grams of carbon, 6.73 grams of hydrogen, and 53.3 grams of oxygen. That makes that determining of grams very straightforward. From there, you'll convert from grams to moles. And once you have moles, whether you got there by dimensional analysis like I did or you used proportions, now you need to find the lowest whole number ratio. Easiest way to do this is to divide by the smallest number of moles. In this case, this is 3.33. Doing this gives you a 1 to 2 to 1 ratio, which allows you to write the empirical formula of CH2O. There you have the entire process, grams to moles to mole ratio. Let's take a look at a second example because in this one you're going to find your grams a little bit differently. Here we're starting with a 0.3250 gram sample of vanillin, and vanillin is made of carbon, hydrogen, and oxygen. And you're told how many grams of carbon there are and how many grams of hydrogen there are. So you already know 2 of the grams. To find the third, you're just going to subtract from the total mass of the sample. Now you can take grams and convert those to moles for each of those different elements. Next, we're going to divide by the smallest number of moles, which is the 0.006406 moles of oxygen. And I'll divide all of these values by that number. As you look at these values, you'll notice that they are not whole numbers. So unfortunately, we're not done. The easiest way to turn these not whole numbers into whole numbers is to think of them as fractions. 2.67, well, 6766, that's 2/3. This is 2 2/3. That's the same thing as 8/3. And 1 is the same thing as 3/3. You'll think of each of these as fractions and then multiply everything by the denominator to find that you would have 8 moles of carbon, 8 moles of hydrogen, and 3 moles of oxygen. this gives you an empirical formula of C8H8O3 that does indeed have a whole number ratio. Now that you know how to find empirical formula, let's talk about how you're going to find a molecular formula. You actually need one additional piece of information. You need to know the actual molar mass of the compound, and there are different experiments that we do to determine that. Once you know the actual molar mass, you just need to see how many times larger that is than the mass of the empirical formula. That's best done as a division problem. You're going to take your actual molar mass and divide that by the mass of the empirical formula. This resulting number will tell you how many times you need to multiply the subscripts in your empirical formula to get to a molecular formula. For example, if I have butane with its empirical formula of C2H5, and if I know its actual mass is 58 grams per mole, I'll take the 58 and I'll divide it by the molar mass for C2H5. So I'll add up 2 carbons and 5 hydrogens, and I get 29.07 grams per mole. So I'll put that in my denominator, and this is equal to 2. So I need to multiply each of those subscripts by 2, which gives me C4H10 for my molecular formula. This is actually how many carbons and hydrogens are in that molecule. Let's work one last problem together where we do everything, where we find the empirical formula and then determine a molecular formula. In this case, we're going to look at ethylene glycol. Ethylene glycol is an antifreeze, and it's the reason you want to make sure you keep your pets away from antifreeze. Ethylene glycol tastes sweet, but it's poisonous. And so while pets would like to drink antifreeze, it'll kill them. So store your antifreeze safely away from your pets. It turns out that ethylene glycol is 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. And this is by mass. Therefore, in our first step, where we need to find grams, we need to turn those percents into a mass. We did this earlier. Think to yourself, how do you do this? If you said, assume you have 100 grams of sample, so those percents become the grams, that's exactly what we need to do. So we'll take each of these percents and we'll turn it into grams. And then we'll take the grams and convert them to moles. Then in order to find the smallest whole number ratio, we'll divide by the smallest number of moles. So I'm going to divide each of these values by 3.22, and I get a 1 to 3 to 1 ratio, giving me an empirical formula of CH3O. Well, this empirical formula has a mass of 31 grams per mole. In order to determine the molecular formula, I'll take the actual molar mass, which is 60, divide it by 31, and I'll get a number that's right about 2. So my molecular formula will have subscripts that are twice as large. C2H6O2 is the molecular formula for ethylene glycol, and it tells you how many of each of those elements are actually in the compound.